Hello, we're going to continue talking today about stereoisomerism and in particularly about compounds like this, which actually we learned that they are enantiomers. This is a carbon atom. Notice, remember that we learned to identify chiral centers as carbon atoms that here is sp3 hybridized and will have 4 different substituents. And this is the mirror image. And these two are not superimposable. If I try to overlap this, I can't. I want you to see that in this side, I'm overlapping white and green. And also here, even though the two on the top here, the two OHs overlap in this group here, the metal. So they are different compounds. So how do we tell one from the other? We need to add something to the name. And we need to determine what we call absolute configuration. This is what we're learning today. So absolute configuration. And what we use for that is that rules developed by 3 chemists. They are Cahn-Ingold-Prelog. So now we're going to learn that. And in doing this, to do that, I'm going to draw a compound, and we're going to determine the absolute configuration of that. So say that I have now, I'm going to put here a chlorine, and here I'm going to put an OH, and I'm going to draw here an H. And I'm going to also draw the enantiomer. So here is my mirror. I'm going to draw OH here. So mirroring what I'm doing, right? So chlorine, and now I am having a hydrogen here. That's a metal. So I have 4 different substituents, so we know we identify that as a chiral center. So how are they different? We know they are. They're not superimposables, even though they're mirror image. They are enantiomers. But first we need to again, explain how can we tell one from the other. We're going to give it, learn how to determine the absolute configuration at the chiral center. So what Cahn-Ingold-Prelog rule uses is prioritizing groups that are the substituent at the chiral center. And it does, the rules is by atomic number. So by the atomic number, we get that. Greater the atomic number, the highest the priority. Priority 1 is the substituent with the highest atomic number of the element directly attached to the carbon. And to remind us a little bit of the what is the atomic number, I'm just going to draw here a part of the periodic table. This is hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and we know atomic number is increasing in this direction, right? That's neon. And right below, I'm going to draw chlorine because I'm going to use it. And so we know this is number 3, 4, 5, 6. This is the atomic number, right? Okay. And now this is bigger. This is because, again, we're going to be prioritizing the groups that are the substituent at the chiral center using the atomic number. And we're going to take into consideration the atom first that is directly attached to the chiral center. This is your chiral center. So now let's do this. And after we do that, the other part of the rule is that we're going to be looking at the sequence of, we need to look at the molecule, say, with the lowest priority. So look at the molecule with the lowest priority away from our view. Say away. And the last part of the rule 3 is that we're going to do priority 1, priority 2, priority 3. And follow this. If we do this, following 1, 2, 3, then we're going to say this is configuration R. If we go this way, This is configuration S. So let's do this in the example now. Now, the highest atomic number, this is my chiral center attached. The highest atomic number here is chlorine. Then let's look here. Oxygen has higher atomic number than carbon. So this will be my priority 2. Then I have here a carbon. Remember, that's a carbon atom with 3 hydrogens attached. That's a metal. So that will be my priority 3. And the lowest atomic number is a hydrogen. So here I have that. And we can do the same in the enantiomer. So here we go. Chlorine is it's the same substituents, right? So this is priority 2. Oxygen is greater atomic number than carbon is. So that will be 3, and that will be 4. In applying what we just did here, let's go and do follow the sequence 1, 2, 3. Highest priority is chlorine, so I'm going to go this way. Then we go to the OH, then we go to the CH3. But I have to have the lowest priority group away from my view. And it is, remember that the convention when we draw these lines is that the 2 solid lines are on the plane, but now the wedges is coming towards you, and the dashes are in. So this is away from my view, the dashed line. So I am viewing it correctly, and I do 1, 2, 3. So clockwise, that is the R configuration. And let's look at the enantiomer now. So the enantiomer here, highest priority is chlorine. And I'm going to go to the second highest priority is the O in them here. So I'm going counterclockwise. So the configuration here is S. And now we learn how to determine configuration following these rules. So atomic number, you're going to be looking first at the atom directly attached at the chiral center. Then we need to look at the molecule with the lowest priority group, and this is priority 4. Lowest priority group away from your view. And lastly, you're going to follow the sequence, the highest priority, second highest. And if you do that rotation clockwise, it will be R configuration, and the opposite, counterclockwise, it will be the S configuration. We're going to be applying this to examples.